How are you guys doing? Happy Tuesday. It's great to see you. Let's get started. Yesterday might have been a little bit tricky, but I looked at the quiz and you guys did a great job. Nice work. We're actually going to be exploring the Molar roadmap a little bit more today. So if you want to pull that up again from yesterday, you can. I have it right here, but I erased all my crazy handwriting because it was hard to read. Anyway, we're going to go over today some Molar Conversions practice. So I'm going to do the 3 example problems with you, and then your homework today is to complete the rest of the document. And like always, you can either print it out, do it with a pen or pencil, and then take a picture of it and submit it, or you can do the assignment digitally and submit that document. So whatever works for you, I don't care. So let's get started. You pulled up Molar Conversions. I have it right here, and we're going to do the example problems together. So the first problem says, if you have 45.2 grams of camel fat, so some kind of chemical that camels have, how many moles of that fat chemical do you have? So I have the chemical written down for you. It's C57H110O6. That's going to be the chemical. And I tell you that there are 45.2 grams of this chemical. Okay. But your goal is not to tell me what the mass is, because I told you what the mass is. You need to convert that mass of the chemical to how many moles of that chemical you have. So what we need to do is convert this number of grams into moles. Do we have a numerical relationship that converts grams to moles? Yeah, it's the molar mass. So we need to figure out what the molar mass of this chemical is. And I did it, but if you look at the periodic table, all you have to do is add the molar mass for carbon 57 times, the molar mass of hydrogen 110 times, and the molar mass of oxygen 6 times altogether, and you end up with 891.48 grams per mole. Okay? And so here's how we're going to do this. We always start with a given number in the problem, which in example 1 is 45.2 grams. And we need to convert that, so we'll use conversion factor. And we have grams on the top here, so we're going to put grams on the bottom here. And the other part of the numerical relationship with the units is grams per mole. So we have grams, and we'll put moles at the top. Okay? So now we're going to drop in our numbers. We know that it's 891.48 grams per 1 mole. So I put a 1 there. And now all we have to do is calculate that. So you grab your calculator and you type in, just like I am, 45.2. And we're going to press divide because this next number is on the bottom. So we divide by 891.48. And we get 0.051, I'm just rounding, moles of this chemical. So there's our answer right there, 0.051. Great job. You did it. You're incredible. Okay, and so that's all you needed to write for number 1. We've just converted the mass of a chemical to the number of moles of that chemical. Cool. We just did this conversion on the Molar roadmap right here. Okay. Well, let's try the next problem. Okay, so you're going to scroll down on your document. The next one is a mole to particle conversion, okay? And so I know I'm going to go from moles of whatever I have to the particles of whatever I have, okay? And so the first thing we always do is we write down the given. So we have 30.6, says 30.6 moles of this same chemical, C57H110O6. Okay, it's the same chemical. But now we're going from moles to particles. Do we have a numerical relationship or a conversion factor that gets us from moles to particles? Yes, we do. You betcha. We do. And it's actually right here. It says that for every mole, I'm going to put moles on the bottom because I have moles on the top, and that way those units will cancel out. And I'm going to put particles, and I'm just going to write P-A-R-T with a period, particles on the top. We know that 1 mole is equivalent to 6.02 times 10 to the 23 particles of whatever that chemical is, right? Because 1 mole is this 6.02 times 10 to the 23 number of things. Okay, well, let's plug that in our calculator and see what we get. We start with 30.6, and I'm going to multiply because this number is on the top of the conversion factor. So I'm going to press times 6.02 second EE 23, and I get, ready, 1.842 times 10 to the 25 particles. There you go, 1.842 times 10 to the 25 particles of camel fat. Wow, that's a lot of particles. Okay, that one was pretty straightforward. We're just doing one conversion factor, and if it didn't make sense, you could rewind me and check it out again. We're going to do one more practice problem, and then I'm going to let you get started on the work for today. So the third and final example is a mass to particle conversion. This one's a little bit trickier, actually twice as tricky. Okay, so it's the same chemical. It's still the camel fat, the C57H110O6. And we have, looks like 53.9 grams. Okay, that's the number that we're starting with. And we're trying to convert from mass to particles. But there's no arrow that goes straight from mass to particles. So we have to go from the mass to the moles and then down to particles. Okay, so this one's going to be a little bit trickier. So if I'm trying to go from mass to moles first, I'm going to put grams on the bottom, moles on the top. The numerical relationship for camel fat between grams and moles is that molar mass, 891.48 grams to 1 mole. Okay? And this is the same molar mass as we used in the first example, but we're not done. What we need to do is convert from moles to particles. Okay? And I put moles on the bottom here because it was on the top there, and that way they'll cancel out and we'll end up with just particles as our units. Okay, so the numerical relationship between moles and particles, we actually just did that one. 1 mole is 6.02 times 10 to the 23 particles. Okay, and so we're going to need our calculator. It's going to be a 2-step calculation. We'll take 53.9 grams, and we're going to divide, because this number's on the bottom, we'll press divide, 891.48, and then we're going to press multiply, because 6.02 times 10 to 23 is on the top, and we'll multiply by 6.02 second EE 23, and we end up with 3.64. 3.64 times 10 to the 22nd particles. And I'm going to write number of particles. It's the same thing. And so that's how you would be able to calculate, if someone gave you grams, how many particles you have of that chemical. You have what it takes. You can do it. So now what you need to do is scroll down and complete the following problems showing your work. You might have to calculate the molar mass, but you know how to do that. If you don't, you can check out the other video, molar mass. Feel free to subscribe, drop a comment, a like, whatever the YouTube people say. You're awesome, and I'll see you tomorrow.